is going to be section 13.4. This is on surface area. Okie dokie, let's get into it. So this is on surface area. So in this section, we're going to talk about the surface area of prisms, cylinders, pyramids, cones, spheres. So let's talk about some terminology. We have surface area, and then we have lateral surface area. Okay, lateral surface area is just the lateral faces. Okay, that's just the sides. The full surface area is the sides and then the bases. You may have one base, you may have two bases. Okay, so the surface area itself is just the sum of the lateral surface areas and the bases. You can think about surface area as the amount of wrapping paper you need to cover all the sides of a gift. Now, the difference between area and surface area is that area is for two-dimensional shapes, surface area is for three-dimensional shapes. Okay, so what we do is we look at a three-dimensional object as a bunch of two-dimensional shapes kind of pieced together. So let's talk about some terminology. Faces, edges, vertices. The faces are the flat surfaces. The edges are those lines where two faces meet. The vertices, or a vertex, is another word for the corner. Okay? That's where edges meet. So just so we're all clear about what I mean when I say faces, edges, vertices. So let's talk about the formulas. The surface area of a cube. The surface area of a cube is 6e squared. That's because there are 6 squares that make up a cube, and each of those squares has an area of e times e is the edge length. Now that thing next to it is called the net. Remember we talked about the nets back in chapter, what was it, 11 or 12? Those are the kind of the unfolding of them. Okay, so if you took a cube and you unfolded it, you would get that net. So that way you can see that there's 1, 2, 3, 4, 5, 6 squares that make up the shape. Okay. A prism, the surface area of a prism is 2a plus ph, where p is the perimeter of the base, h is the height of the prism, and a is the area of the base. So the 2a is the two bases areas. The pH is the area of that long rectangle that's formed when you open that prism up. Here, I've got a whole bunch of these shapes. I should have had this ready to go. Here we are. So like this is a 1, 2, 3, so it's a hexagonal prism. So if I were to open this bad boy up, you can see that we get 2 hexagons for the base, and we get this, which is a bunch of the rectangle sides if it's a right prism. And if you open it up, you can see you form one really long rectangle. The length of this long rectangle is the perimeter of the base. And then this is the height of the prism. So you can see if I fold it back up here, this is the height of the prism. And then this, when you unfold it. So that's where that formula comes from. All right. The surface area of a rectangular prism, that's given by the formula 2L plus 2W plus 2WH plus 2LH. So what is that one? What's that formula about? So let's look at this one, the right rectangular prism. So here's what we get. We get that when we unfold it, we have the 2 bases, and then we have 4 sides. Now, really, what we have is, the 2 bases, these 2 sides, and these 2 sides. So we have 6 total sides, and the opposite sides are congruent. So we have the 2LW. Okay, that's the top and the bottom. The 2WH are the sides. The two LH are the front and the back. So this is really just the same formula as the 2A plus pH. So remember from the prism over here, we had 2A plus pH. You could use that here as well, because the 2A is the 2LW. P is 2L plus 2W. So I just wanted to show you that if you see this formula for a prism, that really this is the same thing as the 2A plus pH. All right, so a cylinder. A cylinder is really just an extension of a prism. When you take a prism, the more sides that you add to it, this is a hexagonal prism. If you start talking about an octagonal prism or say a 23-gon prism, then the more sides you add, the more circular it looks. Okay? Now, the cylinder is actually pretty cool because I think it's actually very unexpected. When you unroll a cylinder, so when I take this thing out, my cylinder, the surface area formula is 2 pi r squared. Not surprising, right? Because it's two circles, right? But then when you unroll this, look at that. It's just a rectangle. Who saw that coming? So that's just a rectangle. Now, the rectangle has an area of length times width. So this distance right here is the height of the cylinder, right? So that's the height. How long is the cylinder? Well, the length of the length of this rectangle. Sorry, I didn't say cylinder. The length of this rectangle is just the circumference. That's the 2 pi r. So the 2 pi r squared is the area of the upper and lower bases. The 2 pi rh is the area of the rectangular lateral side. This rectangle has a length that's the circumference, and then the height is the width. So again, I like to explain the formulas so that you don't think that they're just a bunch of random things just strewn together. That's one thing that's the beauty of math, is that so much of it is interconnected and is explainable that you don't have to do a lot of memorizing if you understand where these things come from. The surface area of a pyramid, right? So a pyramid has a surface area of A plus 1/2 PL. Okay? And I use those little cursive L's because I don't want it to look like a 1 or an I, so I use those little cursive L's on there. All right, so where does this come from? A is the area of the base, right? There's only one base on a pyramid. And then there's triangular sides. So what's the area of a triangle? Well, it's 1/2 base times height, right? So if you add up all 4 of those triangles, that 1/2 base times height, the height there is that L, that lateral, that slant height. And then each one of those has a base that's the same all the way around. So there's where your perimeter comes in. That's adding up all 4 of those triangles, in this case 4 because it's a square pyramid. All right, the surface area of a cone. This one's pretty cool because it's just an extension of a pyramid. Just like the cylinder was an extension of the prism, this cone is a smoothed out version of pyramid. Now, the surface area of this one is A plus 1/2 CL. So the area of the base, circular base, plus, now remember, 1/2 base times height, right? So 1/2 the perimeter. Well, the perimeter is the circumference times the slant height. This is not a really easy shape to determine the area for. So what we did instead was utilize the formula for the pyramid and say, okay, 1/2 perimeter times slant height. 1/2 perimeter, because it's a circle, the perimeter is the circumference, times L, that slant height. Now, this formula can also be written in a couple of other different ways. And I say that because I prefer these that are in red a lot more so than the other one. Because the other one is a little harder to manipulate, right? Because you have to be able to find that circumference. So for me, I prefer to use the pi r squared, because there's the area of your circle, the pi r square root of h squared plus r squared. While that formula looks nastier, it's actually more usable because a lot of times you're not given that slant height of L. You'll be given the height of the cone. So the height of the cone is this distance right here inside the cone. The slant height is just that. It's that height. I'm a 7:30 alarm on my phone there. So the slant height is just that. It's that height of the slant. Those are different distances. So H and L are often confused, but they are different distances. So a lot of times with these, when you're doing an example, they won't give you L, but they will give you H and R. That's why I like that version of it, because even though it looks more complicated, it's easier to plug and chug. Oh. This kind of shows you what that cone would open up to be if you had just like a whole bunch of little triangles. You know, kind of, again, emphasizing the fact that it's an extension of a pyramid. A sphere. All right, this one, you're just going to have to take my word for it. The surface area is 4 pi r squared. Okay. We derive, I think, yeah, we derive the surface area in Calculus 2. We derive using cross sections. And we talk about, you know, the area and the volume and stuff in Calc 2. But for now, just gotta trust me. Okay, so now that we have all these formulas, you do not have to memorize any of these formulas, but you have to know when to use them and how to use them. So you have to know which formula to use and how to use it. This is a prism, so we're going to use the formula for, you guessed it, a prism, specifically a right triangular one. Right, because it's straight up and down, 90-degree angle of the sides with the base. Triangular because it's got a triangle as its upper and lower bases. The surface area then is going to be the area of the top and the bottom triangles, and then the area of the 3 rectangular sides. So the area of the base is 1/2 3 times 4, 1/2 base times height. Now this is a little weird because you have to look at this triangle separate. So in this triangle down here, the base is 3, the height is 4. Don't get that confused with the height of the prism. I'm talking about the height of just this triangular base. The perimeter is 3 plus 4 plus 5. The height of the prism is 10. So using this formula for the prism, surface area is 2A plus PH. I just found all those individual components. Remember, A is the area of the base. And then just plugged these in. All right. Example 2, find the surface area of the pyramid. So we're going to utilize, again, the surface area formula that is the area of the base plus 1/2 the perimeter times the slant height. The area of the base is a square. So the area is 4 times 4. The perimeter is 4 plus 4 plus 4 plus 4 because it's a square. So it's also 4 times 4. The slant height is 5. Remember the difference between the height of the pyramid and the slant height. Remember the height goes through the middle here. The slant height is along the side of the shape. So using the formula 1/2 PL plus A, plugging in those numbers that we found, we get the surface area of the pyramid is 56 centimeters squared. All right, let's find the surface area of the cone. The radius is 3. The slant height is 5, not the height. The slant height is 5. So using my formula for surface area, I'm choosing this formula, the pi r squared plus pi rl. Okay, I'm picking that formula to use because I was given L. So let me just quickly zoom back here. You see this one down here? I don't particularly like this formula for the surface area. It's the most condensed one. I prefer either one of these two down here in red. Now the reason for that is because a lot of times you're either given L or you're not. If you're not given L, then this one's better, the top one. We were given L, the slant height. So this one is the better one to use, the pi r squared plus pi r L. There's a formula sheet on the last slide, so you don't have to memorize these. So where were we? Oh, so pi r squared plus pi r L. So we're going to plug in R is 3, L is 5. There you go. Boom. I left pi in my answer, so 24 pi, because that's what my lab does for a lot of these. Okay, so I did find some extra examples online. So I didn't want to hit you with too many examples, but I did just go ahead and found one on the surface area, that really like lays it out. It doesn't just, here's an example, here's the answer. I liked this one because it really had a whole bunch of arrows and explanations. So this is an extra example for you to look over for a sphere. This is an extra example I found as well. It just happened to be labeled practice problem 1. So that's a rectangular prism example, and then a pyramid. So another pyramid example. All right. This is the end of 13.4. So here's the formula sheet I was telling you about. If you want to print this one out, you can. It does have all of these formulas that I was talking about on here for you. So if you want to keep this as a quick reference guide, that way you don't have to worry about making your own formula sheet and keeping those handy when you're doing this. So, all right, that does finish us up for section 13.4. Had to look it up. I don't remember what section we're on. So, okay, one more section to go and we will finish up this class, and that's going to be on volume. So, all right, bye.